when we add or subtract fractions, we can only do that to fractions that are similar to one another. And the way we know that they're similar is if they have a common denominator. And that means the number in the bottom of the fraction is the same. If we don't have numbers in the bottom of the fraction, like some examples we'll see in a minute, then we need to find common denominators. We do that by using the same method, equivalent fractions, that we have videos on before. But once you've got a common denominator, it's dead easy. We just keep that denominator. It stays the same. We only ever add or subtract the top lines, the numerators. So for example, in this first one, 1/7 plus 3/7, you'll notice we do have a common denominator. 7 is in the bottom and the top. And so the first thing I'm going to do is I'm going to write down that denominator. It doesn't change. Now, the numerators, 1 plus 3 is 4. And so my answer is 4/7. It's the same with subtraction. In this bottom sum, 3/8 minus 1/8, again we have a common denominator of 8. So the first thing that I'm going to do is keep that denominator of 8. And now I'm doing the subtraction. 3 minus 1 is 2. And so our answer is 2/8. Now we should always be on the lookout for, can we simplify final answers? So 2/8, I know, can be divided. 2 on the top divided by 2 is 1. And 8 divided by 2 is 4. So 2/8 is 1/4. In these three examples, the problem is that we don't yet have a common denominator. 3 and 5 are different, 3 and 9 are different, 20 and 8 are different. So what we need to do is change the two fractions and find equivalent fractions with the same denominator. So I look at 5 and I look at 3 and I say, okay, what's the smallest number 5 and 3 go into? And that's 15. So I'm going to change this into a fraction, so many 15ths plus so many 15ths. And this is when my equivalent fractions come in. What do I have to do to 5 to get 15? I multiply by 3. So whatever I do to the bottom, also do to the top. So 2 times 3 is 6. Looking at the other fraction, 3 times what gives 15? Well, 3 5s are 15. So whatever I do to the bottom, I do to the top. And so 1 times 5 is 5. And now we have a common denominator, so we can add them together. The denominator always stays the same. So 15 stays as 15. But on the top, 6 plus 5 is 11. In this second example, subtraction, same sort of thing. This time you'll notice we have 3 and 9. And actually, the smallest number that both those go into is 9. I don't need to change the second fraction. So I leave it as 2/9. The first fraction I want is a fraction over 9. So 3 watts are 9. 3 3s are 9. So whatever I do to the bottom, do to the top. 2 times 3 is 6. And so I have 6/9 minus 2/9. We have a common denominator, and that denominator is 9. So it stays the same. 6 minus 2 is 4. 4/9. And with both these answers, you see, there's nothing that goes into the top and also into the bottom. Nothing goes into 4 and also into 9. So it's simplified as far as possible. And finally, in this last example, you'll notice we have a denominator of 20 and a denominator of 8. And sometimes you can think of if you can't think, you say, okay, 20 and 8 both go into 160. We multiply these two values. But actually, it's much easier if we can find a smaller value that they both go into. And I know that 20 goes into 40, and 8 also goes into 40. So we're going to find the equivalent fractions. 20 times 2 gives me 40, so whatever I do to the bottom, I do to the top. 3 times 2 is 6. Same thing with the other fraction. 8 times what gives me 40? Well, 8 5s are 40. 5 times 5 is 25. And so we have two equivalent fractions with the same denominator, a common denominator. That denominator is going to stay, and we simply add the tops. 6 and 25 is 31. And again, 31 and 40 share nothing in common.